Right, 8.3 geometric sequences and series. Right, the first 5 terms of the geometric sequence whose first term is 9 and whose common ratio is 3. So basically what they're saying is, let's say I'll write this down a little more formally. A1, that's an A, believe it or not. A1 is equal to 9, and they want to know what A2 is, right? So all you're going to do is you're going to take your previous one and you're going to multiply it by 3, which gives you 27. Then they also want A3, which is going to be 27 times 3, which is 81. And they want A4, which is going to be 81 times 3, which will give you 243. And then they want A5, which is 243 times 3, which will give you 729. Now, that's kind of a long way of doing it. But there's a general formula that you can use to find the nth term of a geometric sequence. And that formula looks kind of like this, which is basically an is equal to the first term multiplied by the common ratio of, so it's ratio to the n minus 1 power. So I could have found any one of these by plugging it into this. So for instance, let's say we wanted to find the second one. Well, we would have plugged in the first one, in this case, which is a 9, times 3, which is the common ratio, to n minus 1. So it's 2 minus 1. And that would have given us 9 times 3 to the first power, which is simply 27, right? Because 3 to the first power is 3. 3 times 9 is 27. Then you could have done the third one. Still would have been the same kind of process. So A1, which in this case, A1 is 9. So you would have put a 9 there, and you would have multiplied that by the common ratio of 3, and it would have been n minus 1. Well, in this case, it's going to be a 3 minus 1. So then you would have had 9 times 3 to the 3 minus 1, or second power. 3 to the second power, we're just doing PEMDAS order of operation. You're going to do the exponent before you do multiplication. So it's going to be 3 times 3, which is 9. 9 times 9 is 81. Then we do the fourth one. It would have been 9 times 3 to the 4 minus 1, which would have been 9 times 3 to the 4 minus 1, which is 3. And then we have 9 times 3 to the third power, which is 27. And 9 times 27 is 243. And then you would have done the last one, which is the fifth one, which would be 9 times 3 to the 5 minus 1, which is 9 times 3 to the fourth, which is 9 times 81, which is 729. So you kind of do it recursively. You can just plug it in over and over again, and you get the answers. Or you can use the formula to get the same kind of result. Okay, so let's try this again. So they gave you the first one right here, so you don't need to find that one. So now you're trying to start with finding the second one. Okay, so if we plug it into this formula they gave you, everywhere they have it in, we're going to plug in a 2 now. So negative 5 times a n minus 1, which in this case is going to be a 2 minus 1. Okay, so you're going to have negative 5, and 2 minus 1 is 1, so that's the first one. So we end up with negative 5 times the first one in the sequence, which is this negative 3 right there. So we have negative 3. So we have negative 5 times negative 3, which is positive 15. Then we're going to go to the third one, which is equal to negative 5 times a to the subscript 3 minus 1, which is negative 5 times a to the subscript 3 minus 1, which is 2, which is negative 5. And the second one, which was this one right there, is going to be 15. And then we have negative 5 times 15, which is negative 75. Then we have a to the fourth is equal to negative 5 times the previous one, which is a to the 4 minus 1, which is negative 5 times a to the third, which is negative 5 times negative 75. which is 375. So the negative times the negative is a positive. And then we want the fifth one, which is negative 5 times a to the 5 minus 1, which is negative 5 times a fourth one, which is negative 5 times positive 375, which is negative 1,875. Okay, now rather than write all this out, we could have used the general formula, which is an is equal to the first term multiplied by the ratio, which is this common ratio, which is this negative 5 right there. So in this case, we know, r in our case is equal to a negative 5. But the general form is r to the n minus 1 power. Okay, so what we would have had in this case, say we wanted to specifically find the last term here, what we could have done is we could have said, well, we start off with a negative 3, and we multiply it by r, which is a negative 5, to the n minus 1 power, which in this case would have been 5 minus 1. That would have given us a negative 3 times negative 5 to the 4th power, which would have given me a negative 3 times positive 625, which would have given me a negative 1,875 right there. So you can either do it recursively, plugging in the previous one into the next one, into the next one, into the next one, just keep plugging it into them, or you can use the general formula to find the nth term. Okay, so the next one says find the second term of the geometric sequence whose first term, a1, is equal to 6,498, and whose common ratio is r is equal to negative 1/2. Okay, so let's try to use the general one. So an is equal to a1 times r to the n minus 1. So in our situation right here, we have our a1 right here, and we have our r right there. So we just plug it in. Oh, and n is 2, because we're looking for the second one. So we have an n of 2. Okay, so let's plug everything in. So we're looking for the second one. So a1 is 6,498. We have r is equal to negative 1/2. And we want it to the n minus 1 power, r2 minus 1 power. That gives us 6,498 times r, which is negative 1/2, to the first power, which means we're simply multiplying 6,498 times a negative, which is 3,249, but a negative one, 3,249. And then we have this one. Write a formula for the nth term of the following geometric sequence when you then use the formula an to find the sixth term of the sequence. Okay. Now, we know that the first term in the sequence is this, 3. They give that one to us. Now to find r, we're going to take the second term, and we are going to divide it by the first term. So in this case, we would say, well, 9 divided by 3 gives us 3. Right? And we can just keep on referencing that too, because we could have just as easily used 27, right? So 27 divided by the previous one, which is 9, still gives me a 3. So we know the common ratio is a 3, given that each additional term in the sequence is 3 times the previous one. Okay, so we have our first term, we have our r. Now let's see. To come up with our own equation, we need, what parts do we need? We need the first term times r to the n minus 1. Okay, looks like we have our first term and we have our r, so we can plug it in there. So this specific one is the first term in the sequence, which is a 3, times r, which is a 3, to the n minus 1. Okay, you could actually simplify that if you wanted to. Because that's a 1, right? So that would be plus n minus 1, which would just give you 3. But we won't mess with that. But yeah, this could actually be simplified. So what we'll have here is we want to know the sixth term. So what we would do is we would say This is the first term, which is a 3, times 3 to the n minus 1, which is 6 minus 1. So it would be 3 times 3 to the 5th, and we would have ended up with 3 to the 6th power, which is 729. Okay, so we have our general formula, which was this one right here is a general formula without simplification, or we could have used this one if we want to simplify a little bit. And then we figured, we found the 6th term in the sequence for this. All right, so write a formula for the general term of the geometric sequence, then use the formula an to find the 7th term of the sequence. Okay, so first we find the first term, which they gave us, which is 1.7. And then they say, well, what is r, right? What is the r? Well, r is, we would take negative 3.4 and we would divide it by 1.7, and that would give us a negative 2. And we could just verify this again if we wanted to. We could just as easily say, well, r is equal to 6.8 divided by negative 3.4, and we still would have gotten the negative 2. So we verified that r is equal to negative 2. Next, we want to build a general formula. So the original general one is first term times the common ratio to the n minus 1 power. So in our case, our first term in the sequence is going to be a 1.7 times. Then we'll have r. R is a negative 2 to the n minus 1. So we want to find the 7th term. So we say 1.7 times negative 2 times n minus 1, n being the 7th, right, because we're looking for the 7th term, and then minus 1. So what we end up with is 1.7 times negative 2 to the 6th power, which gives us 1.7 times. Now, a negative to the 6th power is going to be a positive, and 2 to the 6th power is going to be a 64. So 1.7 times 64 is 108.8.